JSON Web Tokens, sometimes called JOTs, JWTs, or incorrectly JOT tokens, which is redundant, are the most common way to secure your web APIs. You may hear me say JOT token, and if I do, just assume I'm doing it ironically for emphasis. Obviously, you don't want to have a JWT token when the T already stands for token. JWTs have three parts. When you look at the string, you'll see there are exactly two periods in it. These are the delimiters of the three parts. Each part is base64 encoded. The first part is the header. The second part, the payload or data. And the last part is the signature. One of the most important things to remember about JOTs is that they are encoded, not encrypted. You should never store secret or sensitive information in a JOT. If you are ever creating your own JWTs, you need to make sure that your 256-bit or more secret is random, and if you're using a string, it must be at least 64 hexadecimal characters long, or at least 43 characters from an upper and lowercase alphanumeric string in order to get enough entropy to make your key difficult to break. The secret that is used to verify the signature must be shared between the Secure Token Server, or STS, and the Web API server that needs to verify the token in the simplest of flows. Otherwise, if you're using a protocol like OAuth, the Web API server will need to have access to the STS to verify the token. Just a reminder, JWTs are encoded, not encrypted. They can be read by anyone with access to them. Never store secrets like passwords or API keys in your JWTs. A typical token flow using a protocol like OAuth 2 might look something like this. First, the client authenticates, typically with an STS or Secure Token Server or another authentication server or service. Assuming the authentication is successful, the user then will request a token and then receives an access token that includes certain claims that identify the user, such as a user ID. Next, the client will cache the access token for future use, and then attaches it as an authorization header on any request that it makes to a resource server, the Web API server it wants to talk to. The server will validate the token. This is important. It's not enough to just send requests with a token on them. The server has to do the validation, or else none of this is going to provide any sense of security. Requests that include a valid token are considered to be authenticated, and assuming the user has permission to make the request, the Web API will return a response. If the token is missing or invalid, the API server will typically return a 401 unauthorized response. And if the user has a valid token but lacks the permission to access the requested resource, then a 403 forbidden may be returned. Alternatively, the API server may choose to return 404s to avoid leaking information about the existence of secured resources. For example, if you try to access a private GitHub repository, even if you're logged in to GitHub, you will get a 404 response if you do not have permission to access that repository. Working with ASP.NET Core Web APIs, there are several NuGet packages you can use to support JWTs. The first is Microsoft.ASP.NET Core.Authentication.JOTBearer package. This provides middleware allowing an application to receive and verify bearer tokens. The second is System.IdentityModel.Tokens.jwt. This package is used to create, serialize, and validate JWTs. Finally, there are many third-party packages available both for general purpose use as well as to support specific authentication providers like Okta, Identity Server, and Azure AD B2C. In this short demo, we're going to look at how to secure individual API endpoints using JOT authentication. Let's start with the endpoints. Note that we have two simple endpoints in this controller, and each one has an authorize attribute applied. The second one goes further and specifies roles as requiring administrator. If we try to access these endpoints without specifying a token, we will receive a 401 unauthorized response. This is true for the common users endpoint, and it's also true for the administrator's endpoint. Looking at the server, the authorization for this ASP.NET Core API is configured using services defined when the app starts up. The details are shown in this configure JWT authentication extension method, which adds authentication services to the app and configures them using the add JWT bearer method. Here, we configure how we intend to validate the token, and we'll see what happens when a certificate whose lifetime has ended is used with a request. This application exposes a login endpoint that returns a valid token if the login is successful. The token creation is done in this token handler class shown here. It creates an instance of the JWT security token class defined in system.identitymodel.tokens.jwt. Creating a token involves specifying its issuer, audience, claims, expiration, not before, and signing credentials. The claims we're including are a unique identifier, or JTI for JWT token identifier, and the user's email and roles. Now, if we return to Postman and we go to the login endpoint, we can log in with a valid non-admin email. We will get back a token that we can copy and paste. Taking this token to the other endpoints that we already were using, we can specify that we want to use a bearer token and replace whatever might be there with the token that we just received. Now, we can make that request, and you'll see that we get a 200 OK from the basic protected from common users endpoint. If we paste the token into the endpoint that's only for administrators, you'll see that we get a 403 forbidden response. That's because the application knows who we are, but we still don't have permission to access this resource. Finally, let's look at the token in JWT.io's debugger to see what's inside. In the payload, you can see our JWT identifier, our email, which is the sub, as well as the claims and the not before and expiration dates, the issuer, and the audience. In this sample app, the expiration is only a few seconds, so if we run back to Postman now and use our expired token to once again access the administrator's endpoint, you'll see that now we get a 401 unauthorized because the token is no longer valid, so it's not able to use it for authentication. That's all you need to get started using JWT tokens with your APIs. Here are some things to remember about JWTs to ensure that you're using them properly and securely. Some best practices for JWT usage based on the JWT attack playbook. First, make sure you're using the latest versions of whatever JWT libraries you choose to use, and regularly patch them. Exploits are discovered with some regularity, then patched with a library update at some point thereafter. Your app remains vulnerable until you install that update, so make it a regular practice to do so. You should always be validating tokens before you consume them. Do not trust tokens that you have not validated. There are options in most libraries to configure which parts of a token you wish to validate, but at a minimum, you should confirm that it is signed with a valid signature using the algorithm you've chosen. You can also validate that the token's lifetime has not expired and that it was intended to use with your API by checking its audience. Here's an example set of options for verifying or validating tokens your API receives. Audience corresponds to the AUD field. Lifetime ensures the current time is between the token's not before or NBF and expiration or EXP settings. Issuer is the ISS field. These properties are specified when you create the token, and validating them helps to ensure someone isn't reusing a token or trying to use a token other than the one that you issued. Attackers can use forged tokens to try to access your APIs. Make sure that in addition to validating the JOT signature, you're also checking that it is not expired, that it is ready to use. Together, these two fields represent the valid lifetime of the token. Make sure it was issued by your trusted issuer, and make sure it is meant for you and is not something that was meant for someone else that someone is trying to use with your API. If you're using certificates instead of shared secret keys, you will want to restrict the certificate URLs. Otherwise, a malicious user could use a token signed by their own certificate at whatever URL they want, and you may accept it as valid. Make sure you're using strong keys and secrets. If a malicious user gains access to a token, which is easily done if they can create an account for themselves, then they may be able to manipulate the token's contents and present the forged token as valid if they're able to determine the secret key that you use to sign the token. If you're curious how easily one can determine a weak key, have a look at the JOT Cracker utility available on GitHub at the URL shown here. It's able to crack the default token shown on the jot.io website with a secret called your 256-bit secret in under 2 hours using just a laptop. Your secrets should be at least 43 alphanumeric characters long and as random as possible. If you're generating and validating keys on a single server, then using symmetric keys can work just fine. However, once you start needing to use multiple servers, asymmetric keys that use a public-private key pair are a much better option. When using this approach, the token issuing server signs tokens using a private key, and other servers can validate the signature by using the corresponding public key. If you're familiar with OpenID Connect, it uses this approach. For example, if you sign into a service using your Google account, Google uses their private key to sign the identity token, and the application then uses Google's public key to verify the signature. The main benefit of using asymmetric keys is that you don't have to share secret keys to enable validation. Because JOTs are issued to the client and are cryptographically signed, you can think of them as immutable. There's no built-in way to invalidate an existing valid token. If you need to invalidate a particular user's access, by default, they will retain access until their current JOT expires. Thus, you should consider using relatively short lifetimes for JOTs and possibly combine them with refresh tokens that can be used periodically to request updated access tokens without user interaction.